In the first week of October, something extraordinary happened almost 30 million kilometers from Earth, and for a few days, the two biggest space programs on the planet found themselves locked in an unexpected race. Not a race to the moon, not a race to Mars, but a race to be the first to show the world a clear picture of a visitor from beyond our solar system, an object so rare that humanity has only ever confirmed the existence of 3 of them in all of recorded history. Its name is 3I Atlas, and if that designation sounds clinical and unremarkable, the object itself is anything but. The 3I tells you everything you need to know about why scientists around the world dropped what they were doing the moment it was spotted. It stands for the third interstellar object ever detected passing through our solar system. Not the third comet, not the third asteroid. The third confirmed visitor from another star system entirely, a chunk of material that formed somewhere else in the galaxy, under the light of a different sun, and has now spent who knows how many millions or even billions of years drifting silently through interstellar space before its path happened to intersect with ours. The first of these visitors, a strange elongated object named Oumuamua, was spotted in 2017 and set off years of scientific debate, partly because its shape and behavior didn't perfectly match anything astronomers had modeled before. The second, a more comet-like object called Borisov, arrived in 2019 and behaved in a way that felt more familiar, more like the icy wanderers we're used to seeing in our own solar system. And now 3I Atlas, first detected in May of 2025, has become the third confirmed member of this incredibly exclusive club, and by far the most closely observed one yet, largely because of a stroke of extraordinary luck in its trajectory. That luck came in the form of Mars. As 3I Atlas made its way through the solar system, its path carried it remarkably close to the red planet, close enough that spacecraft already in Mars orbit, machines that were never designed or launched with the purpose of studying interstellar objects, suddenly found themselves in the perfect position to observe one up close. And this is where the story gets genuinely thrilling, because 2 space agencies had hardware in exactly the right place at exactly the right time. China's National Space Administration with its Tianwen-1 orbiter, and NASA with its Mars Reconnaissance Orbiter. Tianwen-1 wasn't a spacecraft built for chasing interstellar visitors. It had already been orbiting Mars for nearly 5 years, quietly conducting its primary mission of mapping the planet's surface and monitoring its atmosphere. But when word came that 3I Atlas would pass within observable range, mission scientists repurposed its high-resolution camera, an instrument called HIRIC, and pointed it toward a target nobody had designed it for. Over several days at the start of October, from a distance of roughly 30 million kilometers, Tianwen-1 captured a sequence of images showing the object as a bright, glowing core surrounded by a hazy, expanding cloud, its coma, stretching out for thousands of miles in the harsh sunlight, with the faint beginning of a tail forming as radiation and solar wind stripped material away from its surface. NASA's Mars Reconnaissance Orbiter captured its own images around the same time, but there was a catch. A U.S. government shutdown was underway, and the bureaucratic gears required to process, review, and release those images to the public had ground to a halt. Days passed, then more days. And while American scientists sat on data they weren't yet permitted to share, China made a decision that would end up defining the headlines for the entire episode. They released their images first. For a brief moment, the story wasn't really about the science at all. It was about the optics of who got there first. Headlines around the world proclaimed that China had beaten NASA to the punch, that Beijing had scooped Washington on one of the most significant astronomical events of the decade off, simply because one agency was free to publish and the other was tangled in political gridlock back home. It made for a great news cycle, but it also somewhat overshadowed the deeper, stranger story sitting quietly underneath all of it. What exactly is this thing barreling through our solar system? And why does it keep behaving in ways that don't fully match expectations? Because here's where things get genuinely interesting. When the Tianwen-1 images were compared across the different days they were taken, scientists noticed the coma and tail structure changing shape in ways tied to the shifting viewing angle as the object moved. Detailed modeling of the dust grains within that cloud suggested something specific. The particles being shed by 3I Atlas tend to be unusually large compared to typical solar system comets, hundreds of micrometers across rather than the finer dust you'd expect. Interestingly, this heavier, chunkier dust pattern echoes what scientists observed with Borisov, the second interstellar object, suggesting that objects formed in other star systems might carry material fundamentally different in composition or structure from the icy bodies native to our own solar neighborhood. In other words, this isn't just a curiosity, it's a data point, a tiny fragment of evidence about how planets and debris form around other distant suns. NASA's own instruments added another layer to the picture. The Hubble Space Telescope, observing the object from its vantage point in Earth orbit, captured a distinctive teardrop-shaped cloud trailing behind the icy core, and early estimates placed the nucleus at up to several kilometers across, an eye-catching figure that only fueled public fascination, even as later refinements brought that estimate down. As the object continued its journey and swept past its closest approach to the Sun, ground-based observatories continued tracking it, capturing images, that showed a faint glowing sphere with a notably different appearance than earlier in its approach, its tail less pronounced, its structure shifting once again as it responded to the intensifying heat and radiation of its solar flyby. Now, no story about a mysterious visitor from beyond our solar system would be complete without somebody raising the question that's impossible to resist. Could this be something other than a natural object? And this is where Harvard astrophysicist Avi Loeb enters the picture, a name that regular followers of interstellar object news will likely already recognize. Loeb built a reputation, and no small amount of controversy, back in 2017 and 2018, when he argued that the very first interstellar visitor, Oumuamua, showed characteristics that couldn't be fully explained by natural comet behavior alone, speculating publicly that it might be an artificial object, potentially even a probe sent by an extraterrestrial civilization. That theory never gained traction among the broader scientific community, most of whom maintained that Oumuamua's odd behavior could still be explained through natural, if unusual, physical processes. But Loeb has remained one of the most vocal and persistent voices calling for closer scrutiny of interstellar visitors ever since, and when 3I Atlas arrived, he was quick to flag its unusual characteristics again, publicly calling on NASA to release its own Mars orbiter images faster, and noting that the object's post-perihelion appearance struck him as unexpectedly similar to how it looked months earlier, a detail he found surprising enough to comment on. That kind of speculation from a credentialed scientist with a public platform is exactly the sort of thing that tends to spiral once it reaches social media. And spiral it did. In the weeks surrounding the Mars flyby, an image began circulating online, supposedly showing 3I Atlas through a solar telescope, appearing to reveal a strange structure with what looked like a heated shield facing the Sun, sparking claims that this wasn't a comet at all, but something built, something with a defined artificial shape. The image spread across social platforms, picked up edits and re-uploads along the way, with users increasingly uncertain of its original source or authenticity. By the time China's verified, official images were released showing the object as it actually appeared, a glowing nucleus with a diffuse natural coma. The viral photo had already done its work, planting a seed of doubt and excitement in millions of people who had no way of independently verifying what they were looking at. This is worth sitting with for a moment, because it says as much about how information spreads today as it does about the object itself. A blurry, unverified image with a dramatic caption can travel across the internet faster than any peer-reviewed observation ever could. And by the time credible institutions catch up with confirmed, calibrated data, the narrative has often already taken hold in the public imagination. The actual verified imagery from Tianwen-1 and from ground-based observatories around the world consistently shows 3I Atlas behaving the way scientists would expect an ancient interstellar comet to behave. A solid icy core, a surrounding cloud of gas and dust released as sunlight heats its surface, and a tail shaped by the pressure of solar radiation. All standard signatures of natural cometary activity, just from a body that didn't originate anywhere near our own sun. None of this means the object isn't remarkable. It absolutely is, just not necessarily in the way viral social media posts might suggest. Consider what 3I Atlas actually represents. A piece of another solar system, potentially older than our own sun, that has spent an almost incomprehensible stretch of time drifting through the emptiness between stars before crossing paths with our little corner of the galaxy. Every photon of light it reflects, every particle of dust it sheds, carries information about the environment it formed in. Information scientists are still working to decode. The unusually large dust grains, the specific way its coma evolved as it neared the sun, the subtle differences between its behavior and that of comets native to our own solar system, these are the real mysteries here, the ones actual astronomers are racing to understand, not through speculation about alien engineering, but through careful and methodical analysis of light curves, spectral data, and orbital mechanics. And this is really just the beginning. China's next mission in its deep space program, Tianwen-2, already launched and currently en route to sample material from a near-Earth object, was partly designed with these kinds of opportunistic observations in mind, a demonstration that as humanity spreads more instruments and spacecraft throughout the solar system, we're building an increasingly capable network for catching future interstellar visitors when they arrive, and they will arrive again. Scientists studying near-Earth objects estimate that interstellar visitors like Oumuamua, Borisov, and 3I, Atlas, may be far more common than previously assumed, simply too faint and too fast to detect, until survey telescopes like Atlas, the very system that spotted this latest object and lent it its name, became sensitive enough to catch them passing through. So while the headlines chase the dramatic angle, China beats NASA. Scientists baffled, is it alien technology? The real story is quieter, slower, and in its own way, even more remarkable. A team of scientists on Earth managed to repurpose a Mars orbiter never built for this purpose, capture images of an object that formed around a star we'll likely never identify, and begin piecing together clues about how planetary systems other than our own actually work. That's not a mystery NASA or China can't explain. It's a mystery they're in the process of explaining, one photon, one dust grain, one careful measurement at a time. And if history with Oumuamua and Borisov is any guide, you'll be studying the data from this brief, fleeting visit for years to come, long after 3I Atlas has continued its journey back out into the darkness between the stars, never to return.